Good morning.
How are you guys doing?
Good.
Good. Oh, it's Cody. How are you, Cody?
Good. How are you?
I'm doing all right. I am doing all right.
Good deal.
And you,
Yeah,
how are classes?
I'm pretty good except for the science block that I took that I thought would be easy, but it's not.
Oh no, what are you taking?
Astronomy.
Oh, I took astronomy and it is a lot harder than one would expect.
Yeah,
Yeah.
I was told it.
Oh,
I was told it would be easier than
yeah.
biology, but not quite as easy as geology.
Yeah.
But yeah, it's all right. It's just overwhelming.
Yeah.
There's due dates like every day.
Oh no.
I have like 2 pages for the syllabus of just due dates.
Oh my gosh. Oh gosh.
Yeah, but it's not too bad. I was fixing to open your quiz, but I figured I'd wait until after your Zoom meeting to do that.
Okay. Yeah, if y'all have the book, if you have and well, I don't know how much the slides, maybe the slides, but definitely the book will help you guys with that. And there's no time limit. You can take it an unlimited amount of times. And I want to say it's the same 25 questions. So if you miss it, when you go back, it'll be the same question. You know what I mean?
Oh, okay.
So yeah.
Cool.
So and I really specifically picked questions that would help you for the test. Okay, so it's like a study
Okay.
for the
And
test.
the test itself doesn't open until Friday, right?
That's right.
And you're
Yeah,
leaving it open all weekend?
I will. Yes.
Okay, cool.
Yes. Yes. Yes.
Yeah, because I work graveyards on Friday and Saturday night, so that's when I do most of my homework.
Okay. Okay.
I did end up doing the quiz this morning. It's
Uh-huh.
actually it's not that hard as I thought it would be. The only thing that kept throwing me off was the identifying, I guess, for one of them, the levels of independent variable and
Okay.
identifying the independent variable. In the one that focuses on snakes, the
Uh-huh.
experiment,
The Albert Bandura study.
yeah, exactly.
Okay.
I wasn't sure how many, let's say, like the independent variable. I didn't know whether it was I figured out that it was the therapy,
Right.
but I end up guessing that it was maybe like the types of snakes, but then I
Oh,
saw that not every group had snakes in it. So
okay. Yeah, and I don't know the exact wording of
yeah.
the paragraph. So bear with me just a little bit on this, but yeah, the Albert Bandura was well known for what, like, observational learning,
Yes.
mimicking, copying, things like that. So he, from what I remember, this study was they had people that were afraid of snakes. They had snake phobias,
Mm-hmm.
and he wanted to test the different types of therapy. So they had like and this one I don't know if it was like a kind of a cognitive therapy where they just talk to you through your anxiety. But I know for sure one of his treatment groups would have been modeling, because that's what he's known for, right? So it would have been where people kind of, you watch somebody else approach a snake and
Yeah.
handle it, right?
Yeah.
Um, and maybe in the wording, it wasn't very well defined. But again, yeah, if you just sit there and kind of read through it and figure out what are their groups, how are the participants being grouped off,
Okay.
and as soon as you see, like, oh, some people are assigned to do this and some people are assigned to this group, right there is that's your independent variable.
Okay.
um, and yeah, and I can see that maybe that it is. It's not might. It is
Huh.
hard
And
sometimes to figure out
yeah, and I did I had to look up again what the levels were.
levels. Yeah,
Yeah, I wasn't sure what I mean, again, I ended up figuring it
you
out,
got it. Yeah,
but because of process of elimination, but
right.
like but I still wasn't sure like what the levels were. Like I know that, for example, there was something, the other example was regarding like picking three types of like spices, and then and a group had to like um I guess they would choose out of those three spices, they would choose their favorite, and then they would fill out like a little like not survey per se, but it's like a questionnaire saying would they take that risk, or I don't know what it was, something like that.
Okay.
And but for that one, when I looked up the definition and when I looked at like an example of it, I
Uh-huh.
was able to identify it was 3 levels,
Yeah.
because of like the mild, high, and whatever other there is.
Right. Right.
And but for the one with the snakes, I wasn't able to identify that clearly.
Okay. Okay. Yeah. And the way sometimes they're written, it's not clear right off, when you first read it. And it can get confusing. And I'm not trying to do it to throw you all off.
Oh,
I'm not
of course.
trying to do a gotcha kind of
No,
thing.
of course.
I want y'all to pass. I want you to learn it. I put those in there because I can guarantee you up at UTEP, they're kind of the ones that are gotcha. You don't get this. You don't understand this. Kind of, I hate that. I hate that way of teaching. But
Yeah. Yeah.
and so yeah, levels. To me, the easiest way to think about it, they're your groups. They're how many groups are in the independent variable. So
Oh, I see. Okay.
yeah, so if say I was testing Tylenol, Motrin, aspirin, and placebo, I would
Mm-hmm.
have 4 levels to that independent variable.
Okay,
And
yes.
and then I think in the multiple choice, sometimes it's a little bit hard because you're having to read how somebody else would describe that independent variable. So let's say in that example with the Tylenol and the Motrin and aspirin and placebo,
Yeah.
I might label that independent variable as medication.
Mm-hmm.
Um,
Of
Someone
course.
else might label it as pain modification. Someone might label it as a headache medication. I don't know. So if you think about it, there's so many different ways that you could name
Yeah.
that independent variable. And so this part is a little bit like when I would do tests face to face, a lot of times, I mean, I would do the multiple choice, but sometimes people just writing them because they're your words, and
Of
when we
course.
go on to do research, how you label something and how you define something, that's purely up to you, and who am I to say, no, you should label it medication. So with the multiple choice, it gets a little bit hard in that sense, but
Okay.
yeah, but I'm glad you worked through it. And, so everybody who's listening, just kind of know that those come up and they're not easy, but in no way am I sitting here trying
Oh,
to make
but
your life
they're
miserable.
no, of course, no.
Yeah,
It's but in general, like that assignment is not as hard as one would think. Like
right.
it's
Oh,
just
okay. The
a lot
whole
of like
quiz.
it. Yeah, it's just it. Like you said, definitely the book helps. The book helps. I would have to sometimes look up again terms that weren't clear on the book
Okay.
in the internet, but like in in general, like it's actually not as hard as you
Okay.
might.
Okay. And again, on those guys, if you want to, get on and ask questions in that chat, that classroom chat where you all can talk to each other, and ask questions to each other and kind of work it out that way. I am 100% okay with that, because, this is a homework assignment. I know it's titled quiz, but don't think of it like that. That's a homework assignment in a regular school year. I'm assuming you all would get together, you would have study buddies, you would do those things. So I'm 100% okay with that, because we still learn that way, right? And sometimes the way someone else words it, just for some reason it clicks, right? I could say it a million times, the book could say it its way, but when someone else tells you what it is, then for some reason it just, oh, that makes sense now. So please, do that with each other too. Okay. All right. Any other? Thank you, Natalia, for your feedback. Cody, I hope you see that as she's trying to tell you it's not as hard as so don't be afraid of it. Not that you are afraid of it, but yeah. Anybody else have any questions? No. Okay, so let's go through this this chapter 4, exploring variability, and get started in this stuff, because this is this is like statistics. This is what we do over and over and over again. So just like central tendency had 3 measurements. We had the mean, the median, and the mode, right, with central tendency. With variability, we also have 3 measurements. We have range, standard deviation, and variance, okay? They sound scary, but they're okay, all right? But variability is so important in statistics, because it allows us to control for differences. I was going to say variability. It allows us to control for those differences. So we know not everybody is the same. We know not everybody has the same biology, experience, education. Not everybody has the same attitudes. Not everybody has the same future ambitions or widely held beliefs. So we know that people can be unpredictable. And so that's the fun part of statistics, is we're trying to control for that and have confidence to say, despite people being so different, we know that this is how they're going to act, or we know that people are going to feel this way, or we're confident that people are going to show up and vote this way, or they're going to pick the blue car over the green car, or whatever it may be. So where the mean tells us this is our average, variability comes in and says, yeah, it's our average, and we know with confidence that this many people will fit this mold. Okay. And what I'm trying to say, let's see, we know, like, say with the number, what did I ask you guys, number of siblings? And I think our number came to like 3.5. I think that was our mean. I believe I might be making that up, but I believe that was the number. And from what I remember, though, a lot of us had quite a few siblings. A lot of us had 5, and then some of us had like 1 or 0. And so I'm not sure if really there was anybody even that had 3 siblings. So when we say this is the mean, a lot of us could have said, that doesn't represent me. I don't have 3 siblings. I don't have 3 siblings. I don't have 3 siblings. And that's where you hear people begin to question statistics, right? Especially in the news, especially around voting time, right? Where people are like, well, I didn't get picked. They didn't survey me, or I didn't vote that way, or whatever it may be. We know that differences are out there, but we take that into consideration. Okay. And so that's what we're going to learn. And you'll see actually that variability and how we measure standard deviation is the main, I don't know, I don't want to say the word thing, but it's so crucial to statistics. Okay. So with that said, I'll move on. Range, standard deviation, and variance. Okay. The range is the absolute easiest thing to calculate. It's a little bit easier even, I thought I could kind of minimize that. Oh, we're here. Okay. It might even be easier than the mode. Okay. So the range, you just, you got to put them in order. You got to put your data points, your raw scores in order, or at least be able to identify what is your highest score and what is your lowest score. Okay. So you don't necessarily have to be a stickler with putting them in order like we did with the median, but I don't want you to leave any little numbers out, right? We've got to identify what's the highest score that we have and what's the lowest score that we have. Okay. And then here comes the hard part. We subtract them. Okay. You take the highest score and you subtract the lowest score, and then that number is your range. Okay. So let's see. I think I have my, oh, I do. Okay. All right. Let's see. I'll draw a little bit here. Or right, I guess I should say. And I'm going to do our ages, okay, because I think that age gives us a good range. Okay. Oh my God, that's horrible. Hold on real quick. I'm telling you, I don't like this pen. I like just my finger a little bit better. Yeah, that's better. And we'll say age. Okay. So anybody willing to share their age? I know ladies have a hard time with this sometimes. So if you lie, we won't know the difference. Okay, so we don't know really how old you are. So if anyone wants to go ahead and throw them out there, what are your ages?
40.
Okay, 40. Okay.
38.
38. Okay.
21.
21. Okay.
18.
18, and I just opened up the chat and saw 23. Okay, anyone else?
19.
19, and then what did I hear, a 25?
35.
Oh, 35. Is that Cynthia? Do I hear your voice?
Yes.
Hi.
Hi.
35. You said that like begrudgingly, like you were sad.
Yes, I am sad. I don't want to be 35.
Aw. 35 is a good number. You know what? All numbers are good. All of our ages are good because the alternative is not good, right? So we want to have an age. All right. Someone else said something?
No, I said it's halfway to 40.
Yeah, it is, but it's all right. Oh, I wrote it twice. I had 35 in my head. I'm going to put mine up. Anybody else? No? All right, I'm going to put mine. Cynthia, this one's harder. I'm 45. What the heck? All right. Anybody else want to throw them out there? Any other ages? I don't know how many people we have in class, so. All right, so we have our ages here. We don't have to rewrite them and put them in order, but at least so we could identify what is our X. Here he has it labeled as XH, meaning like X high, our highest value. and XL indicating our lowest value, X low. Okay. Sometimes you see it like this too. And in fact, I can't guarantee that it's not like this in the book, but I think I tried to match the same words that they use in the textbook. But sometimes you see it as X max minus X min, meaning the maximum score minus the minimum score. Okay, I try and tell you all these different words like this, not to confuse you in any way, but just so that you can see statistics is really annoying, that we don't have just one word for things, and so that you'll be prepared when and if you go somewhere else and do statistics somewhere else, you won't get too confused. You'll go, oh yeah, I remember that. Okay, so X max minus X min. Okay, I think I'm the maximum. And 18, who's our 18-year-old? Wait, no, we're not gonna, is everyone there? Are people there? Did I lose them? I don't know, I don't hear anybody anymore. Oh, we're here, okay.
I'm
Yeah,
still
I
here.
heard some.
I'm still here.
Okay, it got really quiet and I was like, oh my gosh, did I leave everybody? Did I lose them? Okay, let's see. So I'm going to get out my phone, right? My trusty calculator here, because we can't trust me to do math like that. I cannot do that in my head. I got 27. Yeah, I guess some confirmation there. Did I do it right?
Yeah.
Okay.
Yeah, I got the same thing.
You got the same thing. Good. All right. There you go. That's it. that is range. Super easy stuff here. Okay. Range is not the best way to describe the variability, but it gives us at least a grasp or a picture of the data that we're looking at. So if you remember back to when I was talking about that example of our made up average for our first exam, when I said it was 75%. And I asked you all to try and give me, how did that make you feel? You would feel a lot better, I believe, if I told you what the range was, at least, right? If I could tell you, well, the range was, I don't know, 70 to 80. I don't know if that would make you feel better, but at least you would know, well, okay, I'm not going to fail because most people scored at least a 70 or, within 70 and 80, although it may not make you feel very comfortable because nobody got an A. Right? If I told you the range was 0 to 100 or the range was 100, now that may make you feel better also, because at least you have the opportunity, okay, I could get a 90 or 100. And some people got a 0, so that might make you feel a little uncomfortable. But you can see what's happening there, right? When we get a picture of the range of values or the range of scores, it allows us to start making a much more educated guess about what that sample or what that population looks like. Okay. All right, so now I'm going to move on to this. Y'all might have already seen this. I want everybody to take a deep breath. Do not panic. These formulas look big and scary, but I promise you they're not as hard as they look. Okay. Anybody having a mild panic attack right now? No, I hope not. Okay. Yeah. You are?
No, for a second, but I'm okay.
But no, I know, and I know they look scary. But I promise you they're not. Now, if I saw this in algebra and they were like, you have to solve for X, I would skip it. I would skip it and I would move on because there's no way. I don't know how to do that, right?
I have something similar to this because I took I don't know if anybody else has taken contemporary math, but oh my God. It has something similar to, yeah, it has a lot of words.
It does. Yeah. So, okay. So let's not stress too much. Okay. First, I'm going to show you here just some of the symbols. Okay. So let's see this one right here. We have S hat. Okay. We call that S hat. It's an S, and he's got a little hat on, right? Whenever we see a hat on a symbol, it means we're estimating it or we're guessing in some way. Okay. So this is an estimated standard deviation. The way that we know it's estimated is this right down here. Okay, and so that's just an indicator right there that that's an estimated standard deviation. We will use this in the future, and this will pretty much be the only one that we're doing in the future, because that is used in sample data when we're trying to use samples to make a guess about a larger population. This is what is used in inferential statistics. Okay. This one right here, this little guy, is when we're talking about the population standard deviation. Okay. That little symbol right there is actually your capital sigma. Okay. Remember, this is sigma right here. This guy was supposed to be an arrow. That's sigma lowercase, actually, and this one is sigma uppercase. That's just information that you can wow and amaze your friends this weekend with. We do not need to know that. And that is for the population. And we know we're working with the population in that sense because of this right here. Okay, I'll go through and erase all this stuff off. That right there, if you remember from chapter 3, don't worry if you don't remember it, that is the population mean. Okay, that's the population mean. Okay, here is sample standard deviation, where we just have an S. Okay, and this is a nice little formula over here for sample standard deviation. We'll learn the differences between this formula right here and another formula, which I think is a lot easier. This formula is what we call the deviation method. And then I will teach you the raw score method, which I think is much, much easier. But just any questions? I haven't shown you how to work them yet, but just any questions about anything on this page right here, other than the whole darn formula. Okay, Natalia, I wanted to go back to what we had talked about before with the X bar. I asked my dad, and there is no significance to it. It does not mean repeat or anything like that. It's just the symbol that they selected, and we don't know why they selected it, but that's just it. So there's no significance in the bar over the X. Okay.
Okay. Thank you.
You're welcome. Yeah, my dad likes to talk about math, so I was happy when I had a math question for him, and when I always bring up all the other terms or words that statistics uses, we do that with symbols too, sometimes, but not always. And sometimes the sample mean you'll just see as a capital M. So people sometimes will use X bar, and sometimes people will use capital M. I don't know. But there's really a big push to try and, like, let's all get on the same page and not make this as complicated as possible, right? So, okay, so these formulas, all right. So like Cynthia was saying that contemporary math, which I don't even know what that is, but you know, these formulas can be big, they can be scary, they, you know, and again, like if we were in algebra and they were making us try and solve for X, I would not even know how to help you. This, we don't have to solve for X. We are going to get all of those values right there, okay? And all we have to do is plug them in the right spot. So it's a lot easier, I promise, than it seems, okay? So this one, I put this up here. I know it looks a little complex and there's a lot of numbers going on, but I wanted it up here so that you can see a problem worked out from beginning to end, okay? And all the numbers are there and they're all represented, and they're going to show you where things, or I will show you where things plug in, okay? So let's start over here at the beginning with a number of classes, okay? And I took this from chapter 3 in our slides where we had this example number of classes, and somebody had 6 classes, somebody has 5, 4, 3, 2, 1, okay? Our sum of X right here, our sum of X is just 6 plus 3 plus 4 plus, or 6 plus 5 plus 4 plus 3 plus 2 plus 1, okay, equals 21. Okay, sum of X is just adding up your X's. N, if we remember, N is the number of data points that we have, or the number of participants. And in this example, it's 6. We have 1, 2, 3, 4, 5, 6 people that participated in this little survey. Okay, we have 6, or 6 data points there, 6 raw scores. Okay. All right. I'm going to move this real quick. How did we do it last time, guys? Or you know what? Maybe I'll just put it over here. I don't know if we really need these things. Okay. So I like to look at the formulas and kind of think of them like a puzzle. Like, what are the pieces that I need to fill out this formula here? Okay. Never mind that this is a capital N and this is a lowercase n right here, because it doesn't matter. This could be a lowercase n, okay, if that didn't work. So that was a little typo on my part. Okay, that could be an n right there. So we have n, right? We have n in our information over here. It's 6, okay? So we have that. What we don't have is this up here, right? Our numerator, okay? We don't have this sigma, which he says, add up what follows me, okay? Add up whatever is after me. And what he's telling us to add up are all the X's minus the mean squared. Okay, what he's telling us to add up are all the X's minus the mean squared. Okay, so how we find this number right here is we take all of our X's in this column right here. We're going to subtract the mean, this column right here, and we're going to square those numbers. When we add them up, we're going to get the sum of the X's minus the means squared. And that's what this number is right here. Okay. So I went back in over here and I typed it all out for you guys. Okay, we're going to work one through on the next slide all on our own. or with me, you know, we're going to work it out, but this one is just showing you what I did. Okay. So in this first one, we take our X, we subtract our mean. How did we get our mean? Now I realize we did it down here. Our mean is the sum of X divided by the number. Okay, so we took 21 divided by 6 gives us 3.5. That's our mean. Right there. Okay, that's where I got 3.5. So 6 minus 3.5 gives us 2.5. 5 minus 3.5 gives us 1.5. 4 minus 3.5 gives us 0.5. Now here we go with the negatives. Who gets scared of negatives? Anybody? Yeah, we don't like negatives, right? This is another reason, excuse me, why I like statistics, because a lot of times we don't have to care about the negatives. Okay, and I'm going to show you in just a minute. All right, so 3 minus 3.5, we get negative 0.5. 2 minus 3.5, we get negative 1.5. And then 1 minus 3.5, we get negative 2.5. Okay, so these are our X's minus the mean, but we need to square them. Okay, we need to square them. So we take 2.5 and square it. Okay, who here, well, you know, I'm not going to ask because y'all probably won't say. I'm going to pull up, thanks, babe. I'm going to pull up my calculator. Okay, can y'all see that too? You can see, you should be able to, right? Yeah. Okay, where can I stick it? Oh, it goes behind that. Okay, well, anyways, I'm going to put it right here on my computer, just in case. This is our calculator. This is our square button right here. Okay, so I'm going to do 2.5 squared. Okay, and that's how I get this number over here, 6.25. Okay.
I'm sorry, I have a quick question.
Yes, please.
Where you getting the 2.5 from and like the 1.5?
Yes, excellent question. So I'm gonna, let me move you guys real quick. Just like in my classes, I never have a big enough whiteboard. Same thing here. I don't have a big enough screen. Who was that? Oh, is it Ismail?
Yeah.
Okay, Ismail, right here. So those numbers came from me taking the X and subtracting the mean for each one. Oh, that did not work. So all of this right here that I just cleared off, all of this again. So I took the 6 and I subtracted the mean and I got 2.5.
Okay, I get it.
Do you see it?
Yes.
Yeah, okay. And thank you so much for asking, because on the computer sometimes, right, it's so hard. And I know it's hard to follow along. I know that. So the X here, 5 minus the 3.5, and I got 1.5. And then that's where this 1.5 is right here. Okay, we see them?
Yeah, okay, I get it now.
You get it? Okay, okay,
yeah.
yes.
So the number of classes and the X, basically?
That's right. The number of classes are our X, and the mean is the 3.5. So verbally, what this is doing is it's taking each person, like this person has 6 classes. This person has 5, right? And what we're doing is we are comparing them to the average or to the mean. We're seeing how are they different from the mean. Well, this person right here was 2.5 different from the mean.